वेलकम टू सारास एनालिटिक्स अरीना। आज का वीडियो ऐसे लोगों के लिए बहुत हेल्पफुल होगा जो पावर बीआई इंटरव्यू की तैयारी कर रहे हैं। अगर आप इंटरव्यू से पहले ये क्वेश्चंस को गो थ्रू करेंगे तो आपकी प्रिपरेशन और स्ट्रॉन्ग हो जाएगी। मैंने आज कुछ कॉमन और इम्पॉर्टेंट पावर बीआई इंटरव्यू क्वेश्चंस रेडी किए हैं जो लास्ट मिनट रिवीजन के लिए परफेक्ट है। चलिए बिना टाइम वेस्ट किए शुरू करते हैं। Let's get ready and do a strong preparation. Question 1. What is data modeling in Power BI? Data modeling is the process of organizing raw data into a structured format to make it easier to analyze and interpret. In Power BI, data modeling helps in creating relationships between multiple tables and optimizing data for better performance and analysis. Data modeling is a fundamental concept in Power BI that ensures data is well structured and optimized for visualization and reporting. A well-structured data model ensures fast and accurate reporting. Second question is, what is the difference between star and snowflake schema? The answer is star schema and snowflake schema are two common data modeling techniques used in Power BI and data warehousing. The key differences between them lie in structure, performance, and storage efficiency. In a star schema, a central fact table is directly connected to multiple dimension tables, forming a star-like structure. It is simple, easy to understand, and optimized for performance since all dimension tables link directly to the fact table. This denormalized approach stores some redundant data to reduce the number of joins, making queries faster. However, it requires more storage space due to data duplication. In contrast, a snowflake schema is a normalized version of the star schema, where dimension tables are further divided into subdimensions. This reduces data redundancy and improves data integrity. While snowflake schema saves storage space, it requires more joins during queries, leading to slower performance compared to star schema. Third question is, what methods can be used to optimize and reduce the file size of a Power BI report? There are multiple ways to achieve this, and you can discuss the points that you find most relevant during your interview. First example is remove unnecessary columns and rows. Before loading data into Power BI, check if there are unnecessary columns or rows that are not required for analysis. Using Power Query, remove these to reduce file size and improve performance. Second point is, use data aggregation instead of detailed data. Instead of loading raw transactional data, prefer summarizing it at a higher level, like total sales per month instead of per day. This reduces the number of rows, making the report lighter and faster. Third point is, optimize data types. Whole numbers are used instead of decimals when decimal precision isn't required. Boolean, true-false, is used instead of text where applicable. Shorter text values are preferred over long descriptions to save space. Fourth point is, reduce high cardinality columns. Columns with too many unique values, like transaction IDs or timestamps, increase file size. Avoid them unless absolutely necessary, and replace them with categorical values where possible. Fifth point is, use a star schema instead of a flat table. Design data model using a star schema where fact tables, like sales transactions, are linked to dimension tables, example customers, products. This avoids data duplication and improves compression efficiency. Sixth point is, limit the use of images and custom visuals. Custom visuals and high-resolution images increase the report size. Try to use built-in visuals and minimize image usage unless it's necessary for branding or insights. Seventh point is, optimize data storage mode. When dealing with large datasets, consider using direct query instead of import mode to fetch only the required data without storing it in Power BI. If using import mode, ensure only necessary tables and fields are loaded. Fourth question is, how do you manage and optimize large datasets in Power BI? Managing and optimizing large datasets in Power BI requires a combination of best practices in data modeling, query optimization, and efficient data loading. Here are some key strategies. Use star schema to organize data using fact and dimension tables to improve performance. Minimize the number of unique values in columns, especially in fact tables. Turn off auto-generated date timetables in Power BI settings to reduce memory consumption. Use query folding to ensure transformations are pushed back to the source, SQL, Power Query, rather than processing them in Power BI. Remove unnecessary columns and rows. Use filters to reduce dataset size. Pre-aggregate data in the source database when possible instead of processing large volumes in Power BI. Optimize DAX formulas by reducing dependencies on row-level calculations. Use incremental refresh to load only new or updated data instead of reloading the entire dataset. Reduce refresh frequency if possible, and refresh during off-peak hours. If dataset is too large, consider keeping the data in the source and querying it live. Identify slow visuals and optimize them. Too many visuals on a single page can slow down report performance. Use a single directional relationship where possible to improve query efficiency. Fifth question is, what is the difference between measure and calculated column? So guys, a measure in Power BI is dynamically calculated at runtime based on user interactions, making it efficient and memory-friendly. It is stored in memory only when used. It is mainly used for aggregations like sum, average, and count. And calculated column is static and computed during data load. It is stored in the dataset, increasing file size. It is useful for row-level calculations like concatenation or creating categories. Now, sixth question is, what are iterators in DAX and how can they be used in calculations? So, iterators in DAX are functions that process data row by row in a table and then return an aggregated result. They apply a calculation to each row before performing operations like sum, average, or count. Common iterator functions. SumX sums values after applying a calculation to each row. AverageX computes the average of calculated values per row. MaxXMinX finds the maximum or minimum value from row-wise calculations. FilterX functions apply row-wise filtering before aggregation. You can see an example where we are calculating row by row total revenue. Also, you should know when to use iterators in situations like when calculations depend on multiple columns per row, when applying row-level logic before aggregation, when filtering before performing a calculation. Also note that iterators can impact performance on large datasets, so use them wisely. Seventh question is, what is the role of Power Query in Power BI? So guys, Power Query is a data transformation and preparation tool in Power BI that helps import, clean, and shape data before loading it into the report. It allows users to perform ETL, extract, transform, load operations without writing complex code. Key roles of Power Query. Data import connects to various data sources like Excel, SQL, APIs, and more. Data cleaning removes duplicates, fills missing values, and corrects errors. Data transformation merges, appends, and reshapes data for analysis. Automation saves transformation steps so data updates automatically. Performance optimization reduces dataset size and complexity before loading into Power BI. Power Query simplifies data preparation, making it easier to create accurate and efficient reports. Next question is, what is drill-through in Power BI and how does it work? So, drill-through in Power BI allows users to navigate from a summary report to a detailed view based on specific data points. It helps in deep analysis by focusing on a selected value or category. Let me give you a simple example. You see a report showing total sales by country. You right-click on India and select Drill Through. A new page opens showing detailed sales data for India only. Now next question is, what is the role of the M language in Power BI? M language is a Power Query formula language. It is used in Power Query for data transformation and manipulation before loading data into Power BI. It is a functional and case-sensitive language designed for handling ETL, extract, transform, load, tasks. Key roles of M language. Data extraction connects to multiple data sources like Excel, SQL, and APIs. Data transformation cleans, reshapes, and filters data. Automation saves transformation steps so data updates automatically. Custom functions creates reusable logic for complex data processing. Performance optimization performs operations before data reaches Power BI, improving speed. M language works behind the scenes in Power Query, helping users transform data efficiently. Now, what is data profiling, and explain it in detail? Data profiling is the process of analyzing and understanding the structure, quality, and characteristics of a dataset before using it for reporting and analysis. It helps identify missing values, duplicates, errors, and inconsistencies in data. Why is data profiling important? Ensures data quality before analysis. Helps in detecting missing, incorrect, or inconsistent data. Assists in data cleaning and transformation. Improves report accuracy and performance. Also, Power BI provides data profiling tools in Power Query to analyze datasets visually. Column distribution shows unique, distinct, and empty values in a column. Column quality displays data validity, valid, empty, or error values. Column profile provides a summary, min, max, average, count, etc. Now the next question is, explain the concept of incremental refresh in Power BI. Incremental refresh is a feature in Power BI that allows you to refresh only new or updated data instead of reloading the entire dataset. This makes data refresh faster, reduces memory usage, and improves performance, especially for large datasets. How incremental refresh works? Instead of reloading all data every time, Power BI divides data into historical data, old data that remains unchanged and is stored in the dataset, and incremental data, only new or modified data that gets refreshed. For example, a sales report contains 5 years of data. Instead of refreshing all 5 years, only the last 1 month is updated. Next question is, what is a custom tooltip in Power BI? So a custom tooltip in Power BI is a user-defined tooltip that appears when you hover over a visual, providing additional context, details, or insights. Unlike default tooltips, which only display basic information about the data point, like values and categories, custom tooltips allow you to design and control the content and formatting. Example use cases, like showing past sales trends when hovering over a current month's data point, or displaying customer details when hovering over a sales region, or maybe providing additional explanations for complex KPIs. Like, first, create a new page in your Power BI desktop report. Click the Format icon in the Visualizations pane, then click on Page Size and select your type as Tooltip. Click on Page Information in the Visualizations pane and give this page a name and turn on the Tooltip feature here. Go to the View tab in the taskbar at the top of the screen and set the page view as actual size. Insert the visualizations you want in your custom tooltip. Turn on your tooltip on your visual. Ensure you select in the page field the tooltip you just made. Next question is, what are fact and dimension tables in data modeling? Fact table in SQL stores quantitative data like numeric facts related to business processes. It contains foreign keys linking to dimension tables and stores measurable values like sales, revenue, or counts. Dimension table in SQL stores descriptive like categorical data that gives context to facts. Each row in a dimension table represents an attribute of an entity, for example like product details, customer information. Now next question is, what is the importance of the Power BI Gateway? The Power BI Gateway is essential for connecting cloud-based Power BI services with on-premises data sources. It enables seamless and secure data transfer, ensuring that reports and dashboards in Power BI stay up to date. The gateway allows Power BI to access on-premises databases, such as SQL Server, Oracle, or SAP, without exposing them directly to the Internet, ensuring data security. With the gateway, you can schedule automatic data refreshes, ensuring that reports always reflect the latest information without manual intervention. Besides Power BI, the gateway works with other Microsoft services like Power Automate, Power Apps, and Azure Analysis Services, allowing integration across platforms. Without the gateway, users would need to manually export and upload data. The gateway eliminates this step by enabling direct queries to on-premises sources. Instead of constantly moving large datasets to the cloud, the gateway facilitates direct query connections, reducing data movement and improving efficiency. What is top-N filters in Power BI? Top-N filters in Power BI allow users to filter a dataset to show only the top or bottom-N values based on a selected measure. This is useful for highlighting key insights, such as the top 10 customers by sales or the bottom 5 performing products. For example, if you have a dataset containing sales data for multiple products, applying a top 5 filter on total sales will show only the 5 best-selling products while hiding the rest. That's all for today's session, and that wraps up our list of the 15 most common Power BI interview questions and answers. I hope this video helps you feel more confident in your interview preparation. If you found this useful, make sure to like, share, and subscribe to Sara's Analytics Arena for more insightful tutorials and career tips in data analytics. Do you have any other Power BI interview questions in mind? Drop them in the comments below, and I might cover them in a future video. Thanks for watching, and best of luck with your interview. See you in the next one.